Okay, this is the video for how to do homework from hour 31. First, number 12, use your straight edge to construct a linear pair of angles. So I'm going to start with the line tool. I'm going to make a line, and I'm going to put a point on that line and create a ray emanating from that point, and that ray creates a linear pair of angles. So angle BCD and angle ACD, a linear pair of angles. Okay, so now we're going to bisect each of those angles. So we're going to use the compass to bisect each angle of the linear pair. So we're not going to use the compass tool, we're going to use this angle bisector tool here. So using the angle bisector tool, we'll just click on the 3 points that make the angle, and there's our first angle bisector. I'm going to make it a dotted line and make it red. Now this long angle bisector goes through point C out the other side, and so to make that problem sort of go away, I'm going to add an extra point to my angle bisector, make a ray from C through E, and then hide this long angle bisector. So now this ray, CE, is a much better looking angle bisector. Let's make that, there we go. Alright, so that's bisecting the right side. Let's repeat that process to bisect the obtuse angle, angle DCA. So we're going to use the angle bisector tool again, and we're going to put a point on that angle bisector, create a ray from this vertex through that point, hide the line, and make the angle bisector stand out. Okay, so there we have two angle bisectors. Angle bisector CE is bisecting the acute angle. Angle bisector CF is bisecting the obtuse angle. You can probably tell right away that if we were to combine this half of the acute angle and this half of the obtuse angle, they would indeed form a 90-degree angle. I'm going to do some measuring now so we can take a look at some numbers. So I'm going to measure some angles here. Angle BCE, it's about 25 degrees. Let's try moving that so it's readable. There we go. And angle ECD is also 25-ish degrees. Next, angle DCF. That would be 64.53, and finally angle FCA, also 64.53 degrees. Okay, let's get that measurement moved over. There we go. Okay, so all four of those add up to 180 degrees. This 50-ish degree angle was bisected to a pair of 25s, and this 130-ish degree angle was bisected to about a bunch of 65-ishes. Okay, so if you add this angle here, the 64.53 and the 25.47, you'll see that those add up to 90 degrees. Okay, algebraically there's a way to explain this, and what it entails is saying that this acute angle, if we call that a variable x, let me get a piece of text here, if we call that acute angle x, and again that's angle BCD, and then the obtuse angle, angle DCA, if we call that y, I hope we all agree that because it's a linear pair, they add up to 180 degrees. Well, if I multiply both sides of this equation by a half, I'll get a half of the sum of x plus y equals a half of 180, and that's 90 degrees. So half of x and half of y, let me put the parentheses back, we'll distribute to the last step, is going to equal 90 degrees. So again, half of x and half of y will have to add up to 90 degrees. That's a bit of an algebraic proof there. Let me make this go away, and we'll move that. There we go. So again, this angle on the right between B, C, and D, we're calling that x. This other angle is y. This is half of x. Each of these is half of x. Each of these is half of y. Together, those two add up to 90. So that's a little bit of an explanation for that. Okay, so that's that. Our conjecture, I guess we're going to make a conjecture out of this, would be that when you bisect both parts of a linear pair, those parts are complementary. Okay, moving on to number 18. Constructing a regular octagon. There's lots of ways to do this, and here's probably one of the easier ways. I'm going to make a line GH, and let's see if we can make that line look a little bit better. There we go. Okay, so line GH. Now I'm going to make the perpendicular bisector of the segment part of line GH. So I'm going to use the perpendicular bisector tool here. Click on point G, click on point H, and now we have the perpendicular bisector of line GH, or segment GH, excuse me. Alright, so I'm going to make this point of intersection. Whoops, I'm going to make the point of intersection right here. And now I'm going to do an angle bisecting. I'm going to bisect, let's see if I can get the right tool, the angle formed between these two lines. And that's all there is to it. You'll notice that the feature that we kind of hated before comes in handy here. It bisected all the angles at the same time. So now we've got 8 lines emanating from that middle point. And if we were to draw a circle now as our last step, kind of our last step, I can use the compass tool for this. My compass setting is from there to there, centered at point I. This point H and point G and the other 6 points will form a regular octagon. So let's make those points. And there's the rest. Alright, let's hide some of these lines that we don't need to look at anymore. So let's see, we got this line, this line, this line, and this line. Good. And now let's connect using the polygon tool. Points. Done. Regular octagon. I move point H. Oops, if I move point H around, that octagon stays an octagon. And I can measure some sides to verify that all the sides are congruent. So we're going to use the measuring tool. And we'll just click those segment distances, and they're all about 2. And all the angles would also be congruent here. If I were to measure them, they would all be the same. So that's it. Basically a pair of perpendicular lines, and then some angle bisectors, and we're set. Alright, hope you enjoyed the video. Hope you got it right.